Hello students, welcome to S2S classes. Today we are going to start the continuity of the exercise 1.2 on the function 1 on 2 or bijective. So for that continuous of this exercise, question number 8, let A and B be set so that function such that A Cartesian B to B Cartesian A such that f of A Cartesian B, f of this ordered pair is equal to B minus A. This is given, is bijective. So according to A Cartesian B is a set of ordered pair set A comma B, such that A belongs to set A, B belongs to set B. Okay, now for x1, x2 we are writing like that, okay, A comma B ordered pair, this not equal to C comma D. If two elements we are taking like that, where A comma B this and C comma D ordered pair, these are two elements of the domain set. Domain set is the Cartesian form. So ordered pair set. Ordered pair are the element of this set. So A comma B one element, C comma D other element. So both elements like that, such that image f of AB is equal to f of CD. This applies the definition this FAB is equal to BA. Like this function, mode of the function like this कि FAB पर अप्लाई कर रहे हैं तो वो आउटपुट BA हो जाता है. Then BA is equal to then this DC. This it means we can say if these are equal, then it means we can say that AB is equal to CD. It means we can say it is 1 1. So this implies F is 1 1. Okay, after that 4 on 2. For on to range set means y is equal to f of x and fx is like this A comma B for every A comma B ordered pair belongs to domain set A Cartesian B domain set. So A comma B for every A comma B belongs to that. So means what is this? So y is equal to this value is given BA. This ordered pair and y is equal to this ordered pair and this ordered pair FAB ordered pair. So this belongs to B Cartesian A. Means y belongs to A, then this belongs to B comma A. इसका मतलब y is equal to B Cartesian A, this set. Okay, and this implies range set is equal to codomain set. F is on to. f is onto, this implies f is 1 1 also and f is onto also, so f is bijective. Hence proved it. Okay, so bijective we have to prove, then hence proved it is bijective. Now next question, other question, question number 5. We are taking question 5. Question number 5. First part, f such that real number to real number and given by, defined by fx is equal to fx is equal to fx is equal to 7 3 minus 4x. This is question number 7. Okay, question 7 we are taking. Now for this first part and second part also we have to check that on real number to real number, on real number to real number, function defined by fx is equal to 1 plus x square. Now prove yeah, then let x1 comma x2 and x1 not equal to x2, x1 less than x2, and for every x1 comma x2 belongs to domain set, and domain set is real number set, such that image at x1 is equal to image at x2, fx1 is equal to fx2. So this implies fx1 value, put here x1 in first part, we are doing proof of first part, then function is fx is equal to 3 minus 4x. So fx1, if putting x1, x value x1, so fx1 is equal to 3 minus 4x1, 3 minus 4x1. x1 belongs to real number and x2 also belongs to real number. So putting x2 now, fx2 value, this is equal to fx2 also 3 minus 4x2. Then simplify, this implies x1 is equal to x2. Hence it is 1 1. So f is 1 1. F is 1 1. Now for on to find the range, then y is equal to fx is equal to fx is equal to 3 minus 4x, 3 minus 4x, this y equal to this. Then take from here x value, then x will be equal to 3 minus y upon 4. This is x. For every x belongs to real number, then for every x belongs to real number, for every x belongs to real number, So 3 minus y, this implies 3 minus y belongs to real number, this implies y belongs to real number. So range set is equal to codomain set, because codomain also real number set and range also real number set. So range set is equal to codomain set. Okay, now we have to say that this is onto. So it is 1 1 also, onto also, f is onto. This implies f is bijective. Okay, now for the next question, this second part, it is 1 1 onto and bijective, but second part we have to see now. Second part, for the second part, let x1 not equal to x2 for every x1 comma x2 belongs to domain set. In second part, domain set also real number, such that the function value at x1 is equal to function value at x2. Any output both same and input different, but this implies we are going to check fx1 in the function, putting x value x1, so 1 plus x1 square, सिंपल, इक्वल. अब इसकी वैल्यू पुट कर देंगे, x2 fx2 will be 1 plus x2 square. Simplify, 1 cancel, then x1 square minus x2 square is equal to 0. Then factor a square minus b square, then a plus b, then x1 plus x2 into x1 minus x2 is equal to 0. This implies x1 plus x2 is equal to 0, x1 minus is equal to minus x2. And if this x1 minus x2 is equal to 0, then x1 is equal to x2. So now see this is applicable. If applicable, then we have to see that it is applicable. But here function you can check. If you are taking any negative real number, then whole square will be positive. Okay. So now example, if we are taking minus 1 x value, so f minus 1 putting to 1 plus minus 1 square, 1 x value minus 1, then it is 2. And f of 1, if you are finding 1 plus 1 square, 1 again 2. So from this example, what is that? Okay, minus 1 and 1, these are different output but image same 2. Then we can say this is many one, so it is not 1 1 by this example. Okay, it is not 1 1. So we have to write f is not 1 1. F is not 1 1. F is not 1 1. Okay, it is many one. Example given. Now after that, for on to y is equal to 1 plus x square. X square greater than equal to 0 for every x belongs to real number. x belongs to रियल नंबर. x रियल नंबर है, कोई भी रियल नंबर है, चाहे नेगेटिव है चाहे पॉजिटिव है, होल स्क्वायर करने पर पॉजिटिव हो जाता है. सो वो वैल्यू हमें 0 या ग्रेटर देन 0. इफ़ x इज 0 then x square 0. If x any negative real number, then also positive will come. If x is positive, then square will be positive. So always this, remember, for every real number, x square will be greater than equal to 0. So x square from here, what is that will be y minus 1. Y minus 1. So now x square greater than equal to 0. So then this x square greater than equal to 0. So put here x square value. So y minus 1 greater than equal 0. Okay. X square value putting here y minus 1 greater than equal 0. Then y greater than equal to 1. Minus 1 will go that side. So range set is equal to greater than and equal 1. So closed interval 1, infinite open. This is a range set. This implies range set is not equal codomain, because codomain set real number set and range set only 1 and greater than 1, all real number. So codomain set. This implies f is not on 2. So f is not bijective. Hence f is not bijective. Now these both questions done, both part done. Now question number 5. Question number 5. Now question 5. What is question 5? Question 5 is so that the sinum function so that the sinum function so that the sinum function f such that R to R, f such that a real number to a real number is defined by fx is equal to 1 if x greater than 0. If x is equal to 0, then it is 0, and if x greater than x less than 0, यानी all negative real number, at all negative real number this output also 1. So this is given. According to that we have to check, so means proof, we have to prove neither 1 1 is neither 1 1 nor on 2, nor on 2. This we have to show. Now proof 1 1 4 1 1, let same thing, let x1 less than x2 comma x1 comma x2 belongs to real number domain set such that image at x1 is equal to image at x2. This implies, now function, nature of the function given, okay, if x all positive real number then 1, x 0 then 0, then less than all negative this. So means nature is that x1 fx1, यहाँ ले लो, केस ले लो, केस फर्स्ट means x1 x2 x1 comma x2 both greater than 0. Okay, in first case greater than 0, दोनों डिफरेंट है, दोनों greater than 0 है, तो मीन्स greater than 0 तो आउटपुट 1 आएगा, आउटपुट सेम होगा, तो आउटपुट सेम है x1 x2. greater than 0 में नहीं, ये नहीं होगा. ओके, क्योंकि एग्जाम्पल x1 is equal to taken any greater than 0 means x1 taken 2 comma x2 taken any greater than 2 3 4 and I have taken 11/2. Let real number. Example this, f of x1 is equal to f of 2 greater than x greater than 0, any real number, that output 1, and f x2 is equal to f 11/2, this also 1. So means this implies at 2 and at 11/2 different but output same, output 1. So it is not, so f is not 1 1. Example this. Okay, one example sufficient for the false. Okay, now for on 2, it is not 1 1, hence prove that it is not 1 1. Now after that, 1 is for on 2 image, for on 2 range y is equal to fx, and fx is equal to y equal to what is there, that is function nature, like this all real number, at all real number. This implies from the given 1 0 1. So this is the set of 2 element. This is the range set. Range set is equal to 0 1 given. This is given. So range is not equal to codomain. Codomain set, real number set, codomain, but range is not equal to codomain. So F is not on 2. Done. So neither 1 1 nor on 2. Hence proved that. Okay. Hence proved. Now next. Clear? Yes. Yes, one question more. Question number 9. Question number 9. Let f n to n be. Question 9. Let f such that natural number 2, natural number domain and codomain also natural number, be defined by Fn, defined by Fn is equal to n plus 1 by 2 if n is odd. N is odd natural number, then n plus 1 by 2. If n is even, then n by 2 output. According to defined this, yani function given like that, defined that क्या output will come on odd days, on even days. Then prove that bijective function or not. Check. Show that it is bijective. Prove that prove that F is bijective. Okay. This we have to prove. Proof of this. One function. 411, what we have to do? This is the definition clear that 411 how can do? Let x1, x2 are not equal and both belongs to natural number such that f x1 is equal to f x2. Both belongs to natural number. This implies case first. What is case first? x1, x2 belongs to odd natural number. Odd natural number. If both here x1, x2, then image fx1. x1 is odd. x1 plus 1 divided by 2. x2 also odd. So x2 odd, then output x2 plus 1 divided by 2. For first case, this implies this cancel, then x1 is equal to x2. This case okay. Now after that, case second, if x1 odd, x2 even, for this case fx1, x1 is odd means x1 plus 1 divided by 2, but x2 even, if x2 even, तो even इनपुट even है तो then even by 2. Now simplify, then x1 is equal to x2 minus 1. This, so here it is not x1 equal to x2 not there, but x1 एक odd है एक even है, तो means this position. So from that we can say no, not 1 1. Example, if you are taking different, you are taking 3, so f3, x1 is 3 odd, then f3 is equal to odd put किया 3 plus 1 divided by 2, 3 plus 1 divided by 2, then 4 by 2, then 2. If we are taking 4 even number different, 4, then 4 divided by 2 is equal to 2. So from this example it is clear that it is many one. So we can say it is not 1 1. So this implies like that at 3, at 4 different input, output same 2. This, hence f is not 1 1. Okay, so 4 on 2, 4 on 2 output we are going to check, means range set. Let y is equal to function y is equal to fn is equal to n plus 1 by 2 if n is odd, okay, n by 2 if n is even, given. According to this given output, y is equal to, if odd we are taking odd means 2n, n is natural number, 2n minus 1 odd. If we are taking odd, so f of this odd, what will be output? F of this odd, put here instead n odd, so n is 2n minus 1, n plus 1 upon 2, simplify, it is n. Okay, and f of even is 2n, generally even taken 2n and general odd taken 2n minus 1, because for every n natural number 2n minus 1 will be odd, you can check. If n is 1, 2 minus 1, 1 odd. If n is 2, 2 to the 4 minus 1, 3. If n is 3, 3 to the 6 minus 1, 5, and so on. So generally for every odd natural number we are taking odd 2n minus 1, and even for the even 2n. 2n is even if n belongs to natural number. So for n belongs to natural number, for every n belongs to natural number, this is even. Okay, even. So for this even we are going to take the output, then f of 2n for the even, put here for the even. If 2n is even, then 2n by 2 output. So this will be equal to 2n by 2, and that will be n. So here n also, then union of both cases, then that is all natural number. So output is so f is on 2, output is range. So range set is equal to natural number set. Codomain also natural number. So range is equal to codomain. This implies f is on 2, but f is not 1 1. So f is not bijective. So hence f is not bijective. Because f is not 1 1. Hence proved. Okay, now 1 1 on 2, clear that. मैं आपको एक बात बताऊं कि आपने जो वाचिंग किया है वो बहुत सराहनीय है। आप लोग सब्सक्राइब भी कर रहे हैं, बट आप कमेंट ज़रूर लिखें, कमेंट नहीं लिख रहे हैं, और वाचिंग करें, और जो भी कोई प्रॉब्लम है उसका कमेंट लिखें। मुझे विश्वास है कि आप ये करेंगे, और आप वीडियो को शेयर करना मत भूलें। लाइक, शेयर एंड सब्सक्राइब, एंड राइट द कमेंट इन कमेंट बॉक्स। थैंक यू।